Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Junior, your math tutor, and I am an instructor of mathematics at the University of Liberia. So in today's lesson, I want to look at finding derivatives of trigonometric inverse functions. Now, in previous lesson, we solved a few other problems under the trigonometric substitution method. So we want to continue using the trigonometric substitution method in finding the derivatives of trigonometric inverse functions. Now, the trig substitution method is a very easy method in solving difficult problems involving trig inverse functions, right? So when you observe that the angle is a kind of complicated angle that if you just go straight and find the derivative of that trig inverse function, it's going to give you a tough time because you need to have, like, for instance, this problem 1 all over the square root of 1 minus x squared. And now this is our x, so we have to square this. Then we differentiate this expression and then we simplify. So it's a kind of difficult thing. Sometimes it's challenging for us to do. But if we bring in some substitution method, it helps us to reduce that stress of the problem. So looking at this problem, we can rewrite this expression as cos inverse of 1 all over the root of 2 times cos of x plus 1 all over the root of 2 times sine of x. So you clearly see that, remember, our aim is to make everything in here to just be cos of a particular angle, right? So based upon that, we have to bring in some tricks. So we see that the expression in here resembles cos of a minus b, which is just equal to cos of a cos of b plus sine of a and sine of b. But now the question is, what is cos of a and what is cos of b? What is sine of a and what is sine of b? So cos of a is the first factor right here. And then cos of b is the second factor. Cos sine of a is the first factor and sine of b is the second factor. So we can say let cos of a equals 1 over the root of 2. So if cos of a equals to 1 over the root of 2, assuming this is a, so if the adjacent side is 1 and the hypotenuse is the root of 2, this shows that this is a 45, 45, 90 degree right triangle. So it means this side is 1. If you want to do that, you can do it, because this is like saying c squared equals to a squared plus b squared. This is our c, so we square it. This is our a, 1 squared plus b squared. So this is just 2 minus 1 equals to b squared. So b is just equal to 1. Now, what is sine of a as well? So sine of a is just 1 all over the root of 2. That is opposite side all over the hypotenuse. And you see, it's the same thing right here. The next thing we need to find is our cos of b. What is cos of b? Cos of b is just equal to cos of x. And then sine of b is just equal to sine of x. So now we can do the substitution in the problem. So we have y equals to cos inverse of cos of x. Now we have 1 all over the root of 2. 1 over root of 2 is equals to cos of a. And then cos of x is just equals to cos of b plus sine of a. 1 over the root of 2 is equal to sine of a. And sine of b is equal to sine of x. So this expression now equates to cos of a minus b. So cos inverse of cos of a minus b is just equal to a minus b. But what is our a and what is our b? So from the beginning of the problem, we had cos of a to be equal to 1 over the root of 2. So we can now solve for, so we can take cos inverse on both sides, so that this gives us a, and then this is just equal to cos inverse of 1 over the root of 2. 1 over the root of 2. So a now becomes cos inverse of 1 over the root of 2 minus, what is b? So let's erase this. So we know that b now is cos inverse of cos of b is just equal to cos inverse of cos of x. So cos inverse of cos of b is equal to b, and then cos inverse of cos of x is equal to x. So this is just equal to x. So we can now differentiate. So we have y prime now to be, now the first one is just a constant, it gives us 0, minus the derivative of x is just 1. So y prime is equal to 1. So this is how we find the derivative of this function. Thanks ever so much for watching, and see you in our next lesson. Thank you.